Now, next it is important to discuss uh, how to represent represent these relationships in the form of tables, right? Already we have shown this, but the question comes like, suppose I have this the first one-to-one relationship. How many tables will I need to represent this relationship? How many tables will be needed? Obviously, one table is needed to represent A. Uh, to represent A, we need one table where A has two attributes, A1 and A2. A1 is the primary key, so it will be unique, and A2 is A2 can repeat because it can have the same values again and again. Similarly, to represent B, I'll use another table. B1 is the primary key, so it will not repeat itself. Everything will be unique. So this is just an example I have taken, and already we have shown that to represent the relationship between A and B, we need another table uh, which will map the records from A to the records in B. So we'll take A1 and B1 to show how the records are matched. For example, in a one-to-one relationship where some records of A are related to some records of B in a one-to-one fashion. Uh, so this is a one-to-one relationship that we have seen. Now, uh, is there any way to minimize the number of tables? Since we are using one table for A, we are using one table for B, and we are using one table for R. So there are three maximum tables that are needed to represent this one-to-one relationship between two entities. Three is the maximum number of tables. But is there any way that we can minimize the number of tables by merging some of the records? It can be done. For example, if we see this example where R is between A and B, R is between A and B. Few records of A are not participating in the relationship, and few records of B are not participating in the relationship. Uh, like record 4 and 5 of A are not participating in this relationship. Similarly, 101 and 104 of B are also not participating in the relationship. So, in that case, is there any way we can minimize the number of tables? It is possible by shifting the relationship table to either the entity A or to the entity B. For example, if I can show instead of just representing A as A, I'll make it as AR. Now AR table will have A1, A2 and B1. So A1 will be 1, 2, 3, 4 and 5. A will be same as A, B, A, C. And B1 has, since 1 is related to 102, 2 is related to 103, and 3 is related to 105. Record 4 and 5 have no relationship with the records in B. So this will be null and this will be null. So in effect, instead of using three tables, I can use one AR table and the table B to represent this one-to-one relationship. So using two tables, I can show I can show this relationship using two tables instead of three. So I have reduced the tables to two. The other option is to shift the relationship towards B. How do I do it? Instead of taking AR, now what will I do? I'll take one table to represent A and another table to represent BR. So how can I do it? Simply merge R with the table B. So it becomes like this: B1, B2 and A1. So B1 is 101, 102, 103, 104, 105. B2 is A, A, B, A and C. Whereas A1, 101 has no corresponding record mapped to A1, so there will be a null. 102 has 103 has 2, 104 also doesn't have any mapping, and 105 has 3. So I can use a table called BR and the table A to represent this one-to-one relationship, or I can use a table called AR and the table B to represent this relationship. So either of these are valid. Either I can merge this relationship with A or I can merge this relationship with B. If I merge the relationship with A, I'll have table AR whose attributes are A1, A2 and B1. A1 is the primary key, and a table B with primary key B1 and B2. So I can represent this relationship using this table, or alternatively I can represent using the table A1, so I mean table A and table BR, where I merge the relationship with table B. So using these two minimum tables, I can represent this relationship. Now suppose if in case there is a full participation from the side of A, there is a full participation from the side of A and a partial participation from the side of B. I'll just take an example. Let me assume that record 5 doesn't exist in A, so that I can, and so it's a full participation from the side of A because all the records in A are existing in this relationship, whereas all the records in B are not still in the relationship because 104 is still not mapped. So it's a partial relationship from the entity B, whereas it's a full relationship from entity A. So in that case, how do I do? In that case, again I can use either three tables maximum, one for A, one for B, and one for R. These are the three maximum number of, using the three tables I can represent this relationship. Or the alternative is again shift the relationship towards A. When I shift the relationship towards A, what happens is that since there is no this, uh, I have to put that A is related to 1, 0. So here only one thing I have to ensure is that when I'm shifting R towards A, I have to put a constraint on B1. What is the constraint? B1 cannot be null. In the previous case, B1 was null. But now, when I'm shifting R towards A, I have to put a constraint on B1 that B1 cannot be null. So in this case, it will become AR, A1, A2, and B1. What is the constraint? B1 not null. So I have to put this constraint to ensure that B1 is not null. Why? Because A is having a total participation with in this relationship. So all the records of A have to participate in the relationship with B. So none of the values of B1 can be null in this relationship. So I can push the relation R towards A and put a constraint on B1 and then use another table to represent B1. Or the other alternative, as was done previously, I can use one table to represent A and push the relationship towards B. When I push the relationship towards B, what is the constraint that I have to put? I have to put the constraint that uh, B1, B2, and A1. I have to put the constraint that A1 cannot be null. Sorry, in this case it is not valid because there is no need of any constraint. Simply I can put BR. That's it. So either I have to use, when I'm pushing towards A, I have to put a constraint on B1. Otherwise, as usual, we can represent in a relationship. Now comes the third part where both the entities are participating in full relationship. That is, both A1 and B1 are participating in this relationship totally. In that case, how many minimum tables will I need? Let me assume that there is no record called. In this case, I just assume that I'll slightly change the. I'll assume that there is no record called 105 and instead of 105, I'll take it to be 104. So there is total participation from both the entities where all the records from A are participating in relationship with B. So in this case, how many minimum tables will I need? Since it's a total participation, I can show everything using one table called A R B table, where I can show A1, A2, B1, B2. Everything can be shown in only one table. So there is only one table needed for this type of relationship. So here I have 1, 2, 3, 4, A, A, B, A. Here I have 1 is mapped to 102, 2 is mapped to 103, 3 is mapped to 104, and 4 is mapped to 105. Some B I have some properties. So I need only one table to represent this relationship where both A and B are in full relationship with each other. So in that case, only one table is needed. I don't need three tables, one for A, one for B, and one for R. I only need one table to represent this relationship. So what happens? This will be only, there will be only one table needed called a R B table, which has the attributes A1, A2, B1, and B2. So in this case, either I can take the primary key as A1 or I can take the primary key as B1. Either of them is okay.